we completed with the class we have completed negative number representation. Today we'll see about the Boolean algebra. Boolean algebra. Boolean algebra. Boolean algebra is nothing but it's this with it deals with the variables a, b, c, and x, y, z, and zeros and ones. Okay. So there are some laws in order to simplify the given expression into minimum number of variables. We are using this Boolean algebra. Okay. So first, I want to explain you about this some Boolean laws, and we'll see some problems related to how to minimize the given expression by applying this Boolean laws. Okay. First is AND law. Okay, AND law. AND law. You know that how you are getting AND law means you know the truth table for AND gate. You have a truth table, that is how you define the truth table for AND gate. If any of the input is 0, the output is 0. Okay, so this is nothing but AND law, no? So you see, first one, A and A equal to what? A and A equal to A. Okay, so A and A equal to A and A equal to A means 0 and 0 equal to 0, and 1 and 1 equal to 0. Okay, this is first one. Okay, see here, A is 0 and 0, so this is 0, and A is 1, 1, so this is 1. Okay. And next, for next law, if you see, A and 0 equal to 0. Okay, A and 0 equal to 0 means so first one and this one. So this is second law. Okay, so that is A is 0 and with 0. What you are getting 0. A is 1 with 0. What you are getting 0. Okay, so this is second law. Third law. Someone is muted. Just you Bharat,
I'm writing something in WhatsApp because we can't say it. Just we are saying the presentation.
tell in start box. You raised your hand. One second, we'll see. Okay, I thought you can't see my content. Okay, one second. One second. I'll share my screen. Now it's visible. Now it's visible. Okay, PPT on. PPT on. PPT I'm asking. Okay, the PPT only I'm seeing. Okay. Now it's visible, no? PPT. Okay, okay. I will tell you that. So we already seen that it is A, B, and output Y. Okay. So once you respond, is it visible, Bharat? Now it's visible?
No, sir.
Okay. So here we see that A dot A and A equal to A. Okay. So
Sir,
this
not
is
visible, sir.
not visible. 1 second. Now, okay.
The screen is visible, sir, but what you are writing not visible, sir.
Now,
Yes, sir. Visible.
okay. So Boolean loss, if you see, okay. So Boolean loss, if you see, first is and law, and law. So you know the truth table. So that means A, B, and Y 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, 0, 1. Okay. If any of the input is 0, the output is 0. So first law is A and A equal to A. Okay. So this one and this one. Okay. This is first law. Let us take 0 and 0 equal to 0 and 1 and 1 equal to what? 1. If A is 0 and this is 0, you are getting 0. If A is 1 and same A is 1, you are getting 1. A itself. Okay. And next, if you see, so if you see A and 0 equal to what? 0. Okay. So A and 0 equal to 0 means you can write this one and this one. Okay. Second one. So that means A is 0, 0. This is 0. A is 1 and A is 1 and 0. This is 0. Okay. And next second one, if you take third one is A and 1 equal to 8. A and 1 equal to A. So from the truth table, if you see, A is 0. Okay. A is 0 with 1 and this one. A is 1 with 1. Okay. This is third one. So that means A is 0 with 1. This is equal to 0. A is 1 with 1. This is 1. Okay. And fourth one, if you see, A and A bar equal to 0. Okay. A and A bar equal to 0 means A is 0. Okay. That complement. Okay. Complement. So A is 0. What is that complement? 1. Okay. A is 1. What is that complement? 0. Okay. So that is A is 0, that complement 1 equal to 0, and A is 1, that complement equal to 0, that is 0. Okay. So these are nothing but the AND loss. Okay. These are nothing but AND loss. And next you have OR loss, OR law. So first you draw the truth table for OR gate. So how you can define the OR gate? If any of the input is 1, the output is 1. Okay. 0, 0, 0, 1, 1, 0, 1, 1. Okay. If any of the input is 1, the output is 1. Both inputs are 0, the output is 0. Okay. So just develop this one, that is A or A equal to what? A. Okay. Ashtala. So A or A equal to A means you take this one and this one. Ashtala. So that means 0 or 0 equal to what? 0. 1 or 1 equal to what? 1 itself. Okay. And the second one, if you see, A or 0 equal to A itself. Okay. So A or 0 equal to A itself means this one and this one. Okay. This is second one. So that means A is 0 with 0. You are getting 0. A is 1 with 0. You are getting 0. Okay. That is second one. Third one, if you see, A or 1 equal to 1. Okay. A is 0 with 1. Okay. This is third one. For the A is 0 with 1, you are getting 1. And A is 1 with 1, you are getting 1. Okay. And fourth one, if you see, A or A bar equal to 1. A or A bar equal to 1. So that means if you see, so A is 0 and with its complement. Okay. And A is 1 with its complement. Okay, so that means A is 0. What is its complement? 1. You are getting 1. A is 1 with its complement 0. This is 1. Okay, so this is nothing but OR law. Okay, and next you have NOT law. NOT law. So what is NOT law? You know the truth table for NOT gate. If it is 0, it is 1. If it is 1, it is 0. So that means y equal to a bar whole bar equal to what? A. A bar whole bar equal to A. Okay. And next, next you have commutative law. Commutative law. So what is this commutative law? So A or B equal to B or E. Okay. A or B equal to B or E. One second. Somebody messaged. No. I will upload. One second. I will upload. Don't worry. I will upload these two. Okay. So, so commutative law. What is commutative law? Commutative law. A or B equal to B or A, and A and B equal to what? B and A. This is commutative law. And associative law. Associative law. So associative law means you need to remember like this. Suppose same either OR gate and AND gate is there. Okay. So associative means same. Okay. So A or B are equal to what? A or B. C. Okay. Same. Either should be OR gate only. Here OR gate will be there. Okay. And next A and B and C equal to what? A and B and C. Either it may be same AND gate or OR gate. Okay. So that is associative law. And next you have distributive law. Distributive law. So what is this distributive law? So that means distributive means you can remember like difference. Okay. So distributive means difference. So what is it difference? Distributive means difference. Difference. So here if you see A and B or C equal to A and B or A and C. Okay. Here you have AND gate and OR gate. Here you have AND gate and OR gate. That's the difference. Okay. So what is the dual? A or B and C equal to what? A or B. So just a dual is nothing but AND will change to OR and OR will change to AND. Okay. So that is dual. Okay. And next, next if you see from the distributive, you will get some absorption law. This mainly we use in the problems. This is A and A or A bar B equal to what? So if you apply distributive law, so this is absorption. Okay, absorption. So A or A bar, A or B. So from R law, you know that this is 1. This is A or B. Okay. So this is nothing but what? A or B. Okay. A or B. A or B. Okay. So this is the redundant. This is the redundant. Okay. So similarly, you can write A bar or AB equal to what? So this becomes the redundant. But if you expand, what you are getting? A bar or A, and next A bar or B. Okay. So this is one. A bar or B. Okay. So this is A bar or B. Okay. A bar or B. Okay. So these are the laws. And one more law you have, De Morgan's law. De Morgan's law. So what is this De Morgan's law? So this is A or B whole bar equal to what? A bar and B bar. Okay. A, B whole bar. Dual of this one. A, B whole bar equal to what? A bar or B bar. Okay. If we represent in gates, this we are going to use realization of this logic expression or logic gates by using only NAND gates and NOR gates. This you need to remember. That is NOR gate. This is NOR gate. This is equivalent to which gate? Let's take this NOR gate. This is equivalent to bubbled and okay, bubbled and NAND gate. AND gate. This is A and B. Okay, so this is ARB whole bar, and this is A B Y equal to what? A bar C bar. Okay, NAND gate is equivalent to what? Which gate? Bubbled or bubbled or. Okay. So this you need to remember. This we are going to use while realization of there. While if you want to realize by using only NAND gates, wherever the AND gates are there, you need to add the bubble at the output. Wherever the OR gates are there, you need to add the bubble at the input. Okay. Why? Because NAND gate equal to what? NAND gate equal to bubbled OR. No? So you need to add the bubble at the input. Suppose if you want to realize by using NOR gates, wherever the OR gates are there, you need to add the bubble at the output. And wherever the AND gates are there, you need to add the bubble at the input. Okay. So like this, you can do. So this is about dual means, you know. So dual means what? Dual of the function. Dual of the function. So what is dual of the function? Just it will change and to or and to or and or to add. Okay, this is dual of the function. Okay, so suppose if you consider let's consider any doubts? Okay, is it okay? Is it fine? Okay. So that is dual of the function. Suppose you see in the distributive law, no? So A and B are C. That is equal to what? A and B or A and C. Okay. So what is the dual of this one? And will change to R, no? So A or B and C. This is equal to what? A or B and A or C. Okay. This is dual of the function. Okay. And next consensus theorem. Consensus theorem. So what is this consensus theorem? So that means AB or A bar C or BC equal to AB or A bar C. Okay. So that means here you have true form and complemented form, and these two variables are there in the third term. This becomes the redundant. Okay. So you'll get only these two terms, that is AB or A bar C. Okay. And what is the dual of this one? So this is ARB and A bar C and BRC equal to what? ARB and A bar C. Okay, A bar C. So I will prove this consensus theorem for this one. Your task is you need to prove for this dual of this one. Okay, so I will take LHS. So AB or A bar C or BC. Okay, so I can write this as 1. Okay, so whatever the missing term is there, that is A bar C plus BC. I can write A or A bar. I can write 1 as A AR A bar no for R la from R la I can write AR A bar equal to what 1. Okay, and next AB or A bar C, ABC, A bar BC. Okay. From this, what you can take common? AB you can take. What you are getting? 1 plus C. From this, what you can take common? From this, you can take A bar C common. You will get 1 plus B. Okay, 1 plus B. So this you can write as AB and 1, A bar C and 1. You know that from R law, we already see AR1 equal to what? 1. Okay, and from AND law, A and 1 equal to 1. No, A, no? So this is AB or A bar, A bar. Okay, so this is nothing but consensus theorem, and your task is you need to prove this one. Okay, you take the LHS and you want to prove this. You need to get R. Okay, so we'll see some sample problems related to this Boolean algebra. How we are applying the Boolean algebra. Okay. So first problem you see AB bar plus A bar or AB whole bar. Okay, you need to minimize the given expression into minimum number of variables. Okay, so how to do? Let us take x equal to AB. X equal to AB. So this is what x bar plus A bar plus x. Okay, whole bar. So you know that from this, from R A or A bar equal to what? 1. No? So this is what? 1 or A bar. Okay, whole bar. So from R law, you can say that A or 1 equal to what? 1. Okay, so this is 1 bar. This is equal to what? 0. Okay, so this is like this. You can. Okay, and the second one you will see. Second one, AB bar, CR, BD, CR, BD. I will write. So A, AB bar, CR, BD, or A bar, B bar. So how to do? So here you multiply what you are getting. AB bar C or AB bar BD or A bar B bar. Okay. So what is this? This is nothing but 0. No, from AND law, you know that A and A bar equal to what? 0. Okay. So this is AB bar C, A bar B bar. Okay. So if you take B bar common, AC or A bar. So from absorption law, you know that A bar or AB, we already see this is nothing but A bar or B. Okay, so this is B bar, A bar, A bar. 1 second. A bar, A bar, A bar or C. A bar or C. So this is A bar or C. So A is the redundant. Okay, it will reduce A bar or C. Okay. So you need to minimize the given expression to minimum number of literals such a way that it will not reduce further. Okay, so that is you need to apply Boolean laws and you need to minimize the given expression. Third one we'll see ABC bar and AR BRC whole bar. Okay, so apply De Morgan's law. So what you are getting? So De Morgan's law, that is we we already seen De Morgan. What is De Morgan's law? AB bar equal to what? A bar or B bar, and next A or B whole bar equal to what? A bar and B bar. Okay. This is nothing but A bar, B bar, C bar. Next A, B, C whole bar. Okay. You multiply. So what you are getting? A bar. 1 second. So this is we'll get separately. A bar, B bar, C bar. Okay. So A bar into A bar, B bar, C bar, or B bar into B bar and A bar, B bar, C bar, or C bar and A bar, B bar, C bar. Okay. So this is nothing but you know that from and law, you know that A and A equal to what? A. Okay. So A bar, B bar, C bar, A bar, B bar. I'm writing one time. Okay. And this is the A bar, C bar. Okay. You know from OR law, what is this? A bar A equal to what? A. Okay. So this you can write as A bar, B bar, C bar. A bar, B bar, C bar. Okay. So like this you can do. Okay. Next. Next we'll see one more problem. A R B bar C, A R B bar C whole bar. Okay, so how to do? So A R B bar C, A R apply De Morgan's law. What you are getting? B bar whole bar or C bar. Okay, so A R B bar C. This is A or B or C bar. Okay. Next you multiply. So A or B bar C A or B bar C B or B bar C C bar. Okay. So anyway, this is 0 and this is 0. You know that A and A bar equal to what? 0. Okay. So what you are getting? A or B bar C A or 0 or 0. Okay. So you are getting A or B bar C A because A or 0 equal to what? A itself. Okay. So if you take A common, you are getting 1 or B C bar. So this is A and 1. This is equal to A. Okay. Next, see this. Next one we see. If x equal to 1, then x plus z into y bar z bar plus xy bar. These are nothing but previous gate questions or IES questions you can practice. Okay. Z bar plus z bar x plus y equal to 1. Okay. So what is the value of, from this is asking what is the value of z? What is the value of z? Okay. So just you substitute. So x equal to 1 means what? So 1 plus z y bar z bar plus 1 and y bar, 1 and y bar, and this is 0 or z bar 1 plus y, 1 or y, that is equal to 1. So anyway, if you consider this is whole thing is some a, so you know that a plus 1 equal to what? 1, no? So this is 1 and a plus 0 equal to what? A. Okay, so you will get z bar, and here this is 1. Okay, this is 1. So and 1 equal to 0. So z bar equal to 0. Here z equal to what? 1. Z equal to 1. Okay. So like this we can do. And 6 to 1 if you take. We have three variables. We have three variables. A, B, C, A, B, and C. Find the output Y. Okay, find the output Y for majority of ones in ABC. There are majority of ones in ABC, then the output is 1. Okay, so three inputs are there. What are the possible combinations? 8 possible combinations. Let us take. This is the output Y. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. Okay, so that means here if two number of ones are 1, the output is 1. So majority of ones are 1, the output is 1. Okay, and if only one is there, means the output is 0. Okay, so you can write the minterm. So what is the minterm? So this is A bar B C, and this is A B bar C, and this is A B C bar. Okay, you write the expression. What you are getting the expression? 1 second, 1 0 0 1 0 and 1 1 1 also there. 1 1 1 7. So this is 1 and this is A B C. Okay, so what is my output? You write this product terms A bar B C or A B bar C or A B C bar or A B C. Okay, so from this, what you can take common? AB you can take common. Okay, so Y equal to what? A bar B C or A B bar C or AB if you take common, you are getting C bar or C. Okay, so this is anyway 1, no? A bar equal to, so this is A bar B C, A B bar C or AB. Okay, we can do with K-map also, but we are now our discussion is only Boolean algebra, so I'm applying the Boolean laws. Okay, A bar B C, you can take A common. What you are getting? B bar C or B. Okay, so if you apply observation law, what you are getting? A bar B C or A. So here this is redundant. You are getting B plus C. Okay, BR. Okay, and you multiply. What you are getting? A bar B C or AB or AC. Okay, AB or AC. From this two, if you take B common, if you take B common, what you are getting? A bar C or A or AC. Again, you apply absorption law. So that is B, A or C or AC. Okay. So here you are getting AB or BC or AC. So this is nothing but 2 out of 3 logic. Okay. So in the collider also you will get the expression for this carry out. So this is nothing but, so majority of ones are 1 means 2 out of 3 logic. So at least 2 ones are 1 means output is 1. Okay. So this is nothing but 2 out of 3 logic. Okay. So dual I told you, no? So just dual means what? So R will change to and will change to R, and zeros will change to ones, and ones will change to zeros. No? So that is dual of the function. Okay. So what is self dual? Dual of the function. Function I told you. Okay. So dual of the function R with and, or with and with or, 1 with 0 and 0 with 1. Okay, so 0 with 1. So this is dual of the function. Suppose self dual is nothing but if you are applying dual FD, when you are getting same function, this is nothing but a self-dual. Okay, this is nothing but self-dual. Okay, let us take one example. Same example, 2 out of 3 logic we'll see. So AB or BC or AC. Okay, we need to find out the self-dual, that is FD. Okay, so if you apply FD, what you are getting? So just AND will change to R and R will change to AND. Okay, so BRC and ARC. Okay, next you can apply the distributive law. So that means B is common. You apply distributive law, what you are getting? B or AC. Okay, B or AC, R and ARC. Okay, ARC. Again, as per distributive law, no, that is ARB and BRC. You can write as ARBC. ARBC. So apply the distributive law. Okay. Next you multiply BA or BC or AC and A or AC and C. Okay. So from AND law, you know that A and A equal to what? A. Okay. So this is nothing but AB, BC, AC plus AC. Okay, or AC. From R law, you know that A or A equal to what? A. Okay. So here you can write this one as AB or BC or AC. Okay. So same function you got, no? So this is nothing but what? Self-dual. Okay. So this is nothing but self-dual. Okay. So this is about the Boolean algebra. I think you understood. Like we seen some laws. Okay, Boolean laws. Okay, we already seen some Boolean laws. AND law, OR law. Next, NOT law, associative law. Okay, distributive law, De Morgan's law, consensus theorem, and a dual of the function. So based on the laws, we seen some problems related to this. Hope you understood this. One second. Thank you. Stopping the recording.